Hey guys, today we're going to talk about, if you look at the very top, our topic today is going to be something called a unit circle. Okay, so a unit circle, unit refers to one, okay, one unit. The radius of this circle that we're dealing with is 1. And so, I mean, I could make this circle whatever I wanted to make it, so we might as well make it something convenient. So a radius of 1 seems pretty helpful. So remember, when we're drawing angles, we're going to draw angles in a coordinate plane. We're always going to put them in standard position, so the vertex of our angle is always going to be right here, which would also be the center of this circle that I'm looking at right now. Okay? So if I have a circle that has a radius of 1, then on the coordinate plane, there's going to be some points that I'm familiar with, like this right here. This is going to be the point 1, 0. This would be 0, 1. Because that's what this radius is. This would be the point -1, 0, and this would be the point 0, -1. Okay? Now, every other point in between here is probably going to look a little weird to us because they're going to be fractions. Okay? These are going to be the only whole numbers you have. Everything else, so if I am looking at some point, like right here, if I'm looking at that point that angle goes through, I'm going over some fraction. I'm not going over 1. I'm going over 3/5 or, I don't know, some weird fraction. Okay? And then I'm going to go up also some fraction because I'm not going up all the way to 1. This is 1, so this is a little bit less than 1. So again, it's some fraction. So when we're looking at the points that are on this unit circle, they're going to look a little weird. So if you look down at the bottom, you'll see some examples. Okay, that is a point that is on a unit circle. Okay, so maybe that's the point that I was just referring to. Go over 3/5, so a little bit more than half. So that'd be halfway, so a little bit more than half, and then go up 4/5, and boom, you're going to land right on that circle. Okay, or this one. Okay, -1/2, and then whatever the heck radical 3/2 would look like as a point. Now that one I'd probably have to put in my calculator to kind of approximate, but that's going to be over here somewhere. So -1/2, go up. That right there, that y value that I just went up is radical 3/2. Not quite sure what that means yet, but that's what we're doing here, okay? So I've got a bunch of points on this unit circle. Now, let's take a look at this point right here. Now, I don't know if that point is really that right there, okay? The only thing I know is if I drop a little vertical, because I want to create a triangle here, there's some things I know about that triangle, and hopefully your vertical line is better than my vertical line. Okay, a couple things I know about this triangle. That point is over some x amount, okay? I went to the right x, and I'm going to go up y. How much y? Not really sure, but I know I'm going over x and I'm going up y. I also know that the hypotenuse is 1, okay, because we've fixed this circle to have a radius of 1. So that I do know. So if you come over here and take a look at our trig functions, they're going to change a little bit. So the sine of, here's my angle, theta, the sine of theta, which is opposite over the hypotenuse, is simply going to be y over 1 or y. If you have a point on a unit circle, that y value, the y value of this point right here, okay, this is a point. It's some xy coordinate. That y coordinate is the sine of the angle. Okay, whatever that is, it is the sine of the angle. The cosine, well, cosine is adjacent over hypotenuse, so in this case, x over 1, which is just plain x. So again, that x coordinate, if that's all I need to know. I just need to know what these two coordinates are. And then I now know the sine and the cosine. So again, you've got to think of this as, this is where some of you are going to have a little bit of trouble. Because think about what I just said. I said the x and the y coordinate, and the y is the sine, which we usually think of first, but that's going to be the second number. The cosine is the x, and the sine is the y. Okay? Now, everything else we can find from those same two numbers as well. So like the tangent. Tangent is the opposite over the adjacent. So it's the y over the x. Okay. So again, if I have this ordered pair, I would just take this number divided by that number, and then that's my answer. Okay? And then the cosecant, secant, and the cotangent, those are just going to be the reciprocals of these. So cosecant would be 1 over the y, secant would be 1 over the x, and then the cotangent would be x over y. Okay? So I've got this triangle. If you look, it says right here, it says apply the Pythagorean theorem. Well, Pythagorean theorem would just say that x squared plus y squared equals 1 squared, or 1. Okay? X squared plus y squared equals 1. Okay? That is something we actually saw first semester. That is the equation of a circle centered at the origin. You don't have like an x minus h or a y minus k because it's centered at the origin. And then that's your radius squared over there, which in this case is just 1. Okay, so this is the Pythagorean theorem of a circle. It's also of a triangle, and it's also the equation of a circle. Now, knowing what we now know about the x and the y, we also know that x is the cosine. So cosine squared plus, we know that y is the sine value, so sine squared equals 1. So x squared plus y squared equals 1, but also the cosine of the angle squared plus the sine of the angle squared also equals 1. Now this has a special name. It's called the Pythagorean identity. I'm not going to talk a whole lot about it right now, but when I do talk about it, you've seen it, and this is what we're talking about, and I'll remind you of that. Okay? So, if you look at the bottom, it says, use the Pythagorean identity to verify that that point is on the unit circle. So in other words, does 3/5 squared plus 4/5 squared equal 1? Is that true? Do those things equal each other? Well, don't grab a calculator. This is not very hard to do. Okay? 3/5 squared, well, 3/5 times 3/5 is 9/25. 4 squared and 5 squared, that's going to be 16/25. And 9 plus 16 is 25. So yeah, that is a point on the unit circle because the point, the x and the y, work in the Pythagorean theorem. Okay? So, then it says, then find the exact values of the 6 trig functions. Okay? So find the sine, the cosine, and the tangent of that point. Well, we just said that the sine of the angle that goes through that point will simply be the y. The sine of the angle is 4/5. I guarantee. And if you draw an angle that goes through that point on the unit circle, the sine of the angle will be 4/5. The cosine of the angle will be 3/5. And the tangent of the angle will be 4/5 over 3/5. The y over the x. It's also the sine over the cosine. Okay, however you look at it, it's going to be 4/5 divided by 3/5. Now, when you have a situation like that, so you have this kind of a complex fraction, you got a fraction being divided by another fraction. Remember, that just means the 4/5. You could, if you're dividing by a fraction, you could multiply by its reciprocal, which would be, in this case, 5/3, which means the 5s would cancel, and you would just get 4/3. Now, once you've seen that enough, you'll see that these two 5s being the same, they're going to cancel each other out and just leave you with the 4, the numerator of this, over the numerator of that. So 4/3, that's your tangent value. The cosecant is going to be 5/4, so just the reciprocal of what we got over here. The secant is 5/3. And the tangent is going to be 3/4, or the cotangent is going to be 3/4. Okay, so number 2, same situation. I have a point that I'm claiming is on the unit circle. Okay, now I'm going to verify it first. I'm going to show you that this point is on the unit circle because x squared plus y squared needs to equal 1. Well, if you take -1/2 and you square it, and you take radical 3 over 2 and you square it, do I get 1 as an answer? Well, a negative squared is a positive. 1/2 squared is 1/4. Radical 3 over 2 squared. Well, radical 3 squared is just going to be 3. The radical is going to cancel. And 2 squared is 4. And sure enough, 1/4 and 3/4 would give you 4/4. So that's 1. So yes, that point is on a unit circle. And so I now know all the trig functions of an angle that would go through that point, because the sine of that angle is just going to be the y value, the radical 3 over 2. The cosine of this angle is just going to be the x value, negative 1/2. And then the tangent of this angle would just be, well, I've got a positive over a negative, so it's going to be negative. The 2's are going to cancel, and I'm just going to leave me with the numbers in the numerator. The radical 3 over 1, which I could just write as, well, I could write it as radical 3 over 1, or I could just write it as radical 3. Then I'm supposed to find the cosecant, the secant, and the cotangent. Well, that's just the reciprocal of these. So 2 over radical 3. You're not going to leave that. You're going to rewrite that as 2 radical 3 over 3. So rationalize it. Okay, the secant is the reciprocal of that. Well, the reciprocal of negative 1/2 is still negative, but it's going to be negative 2 over 1, or just negative 2. Okay, and then the cotangent is going to be the reciprocal of this. So again, it's still negative, but it's going to be, now it's flipped, so it's 1 over radical 3, which we're going to write as radical 3 over 3, because we're going to rationalize it. Okay? All right, so now what I want to do is I want to kind of just zoom in on quadrant 1. So we can kind of look at what is happening here, just in this quadrant where everything's positive, the angles are nice acute angles. It'll probably make a little bit more sense to us. And then later, we'll kind of expand this and look at the circle as a whole, but right now we're just going to zoom in here. So what do we know about this angle? Well, we know the degrees that we're going to be dealing with. This would be 0 degrees. Okay. This would be 90 degrees. So over here, this is actually where the 90 is supposed to be, 90 degrees. We're going to be dealing with 45 degree angles. So cut that in half, you get 45. And we are also going to be looking at 30 degree angles and 60 degree angles. Okay, those are our angle measures that are going to be very important to us as we move forward. We're going to use these all the time. Okay, now in radians, what are those? Well, this is still 0 radians, so that's what this outer row is going to be. Remember, most of these are going to be fractions. I'm going to use this little blank as like the fraction bar. Okay, so that's 0. This is pi over 2. Pi over 2. If you cut that in half, you get pi over 4, so that'd be 45 degrees. So pi over 4. And then these two right here. So look at 60 degrees. 60 is, if you think about 180 degrees, 60 is 1/3 of the way to 180. Okay, 60, you've got 60, then 120, then 180. Okay, so it's 1/3 of the way there. But in radians, that 180 is pi. So you are 1/3 of the way to pi. Well, so that's what that is, pi over 3. And then 30 is half of 60. So the fraction is going to be half of pi over 3, which would be pi over 6. Okay? Now, those are going to be important. You're going to need to learn those. Okay? Now, what about these points? What about these points that are on the unit circle? Now, a couple of them I know. I know this is going to be the point over 1, because it's a unit circle. The radius is 1. So this is going to be the point 1, 0. And then this would be the point 0, 1. But like I said, these are going to be weird because they're going to be these weird little fractions. So let's use, we've got a 30, a 45, and a 60. So let's use our good old 30, 60, 90, and 45, 45, 90 triangles to see if we can kind of make sense of what's going on. So first off, remember, let's look at 30 first. So remember, this radius is 1. When we look at a 30, 60, 90, we're usually given the ratio of 1 to 2 to radical 3. But we'd really like this hypotenuse to be a 1 because that's what our radius is. Okay, let's just take all of these things and divide them by 2. Right? We're gonna condense them down. As long as we do it proportionally, it's still going to be the same angle. So we're going to think of this as 1. This is 1/2, and this is radical 3 over 2. So if I'm looking at the sine of this angle, or this opposite side over here, okay, it's just going to be 1/2. Okay, this opposite side, so this y value is 1/2, and this x side is radical 3 over 2. So that's what that point is. That point is go over radical 3 over 2. If you want to kind of understand what's going on here, radical 3 divided by 2 is like 0.866. Okay, so we're going over like 0.866, and then we're going up 1/2. And that's where we're landing. That's the xy coordinate of that point, but we're going to write them as fractions. Radical 3 over 2, comma, 1 over 2. That's it. Now, from the perspective of the 60-degree angle, okay, so now everything's kind of flipping on us. So here's our 60-degree angle. We're only going over 1/2. That's the side that is adjacent to our 60-degree angle. Okay, so we're going over 1/2, so that's our x amount, 1/2, and then we're going to be going up that radical 3 over 2. And then the 45-degree angle. So again, here's our 45, 45, 90 triangle, but this one has sides that are 1 unit in length, and it has the hypotenuse that's radical 2. I don't want that. I want a hypotenuse of 1, so I'm going to divide that by radical 2. But that means I have to divide that by radical 2 and divide that by radical 2. Now all my sides are going to match this triangle. Now what the heck is 1 over radical 2? Well, it's radical 2 over 2, because we're not going to write it with the radical 2 in the bottom. So that is the y value, or the y direction of this triangle that I would have over here. And that's also going to be the x value of this triangle. So to get to this point on a unit circle, we would go over whatever radical 2 over 2 is. It's like 0.7-ish, a little bit more. Okay, so we're going to go over a little bit more than 1/2, and then we're going to go up a little bit more than 1/2. Radical 2 over 2 and radical 2 over 2. Now, what this is going to do is it's going to allow us to kind of fill in our chart a little bit more. So this is a chart that we came up with on day 1, and we only had these 3 columns filled in. We also didn't know what a radian was. So if I give you this chart, it's going to start with 0 degrees, 30, 45, 60, and then 90. Then you need to know the radians. So 0 is 0. 90 is pi over 2. Remember, cut that in half, you'll get pi over 4. 60 degrees is 1/3, or just remember that pi over 3 would be between pi over 4 and pi over 2, right? You got a denominator of 4, you got a denominator of 2, so it's going to be a denominator of 3, so pi over 3. But then 60, if you cut it in half to get 30, you're going to cut this in half. Well, cutting this in half means multiplying it by 1/2, so that gives you pi over 6. So you've got to know how to do that. Okay, eventually I'm going to give you this chart, a blank chart, and you're going to have a quiz. It'll be a chart quiz. I'm just going to give you the chart and say, here, fill it out. Okay, and you've got to be able to plug in all this information. So let's look at the sine. So the sine, remember what we said on the front. If you have a radius of 1, the sine are just those y values. 0, 1/2, radical 2 over 2, radical 3 over 2, and then 1. Those are your y values. 0, 1 over 2, radical 2 over 2, radical 3 over 2, and then 1. Now, these three we actually knew already. Okay, we knew that the sine of a 30-degree angle was 1/2, because if you look at a 30-degree angle, you get 1 over 2, and that's the sine, right? Now, what's the cosine? The cosine are these x values. Would be the 1, the radical 3 over 2, the radical 2 over 2, the 1/2, and the 0, which is the exact opposite of what I just said when I did the sine values. So the cosine row, so here's what you need to know. You need to know this row right here. 0, 1/2, so 1 over 2, radical 2 over 2, radical 3 over 2, and then 1. And then your cosine row is that row backwards. So again, you're going to have to be able to fill out this chart. So if you can remember this row, you now know the cosine row. So you're just going to write 0. I write it from right to left. I write the exact same numbers, but I go from right to left. 0, 1/2, radical 2 over 2, radical 3 over 2, and 1. Okay, cosine are your x values. Tangent is the y over the x. Y over the x, which is also the sine over the cosine. In other words, it's this row divided by this row. So for any column you're in, just take this number divided by this number. This is not something to memorize. You're just going to do the math. 0 divided by 1 is 0. 1/2 divided by radical 3 over 2. Now remember, you've got two denominators that are the same. So they're going to cancel each other out and just leave you with this numerator over this denominator, which is 1 over radical 3. You're not going to leave it that way. You're going to write it as radical 3 over 3. That's the tangent of a 30-degree angle. 45-degree angle, well, this over this, they're the same. So they're going to be 1. How about this one? Radical 3 over 2 over 1 over 2. The 2's cancel, and you just get radical 3 over 1, which is the exact same number we got when we did it looking at the special right triangles on day 1. How about the last one? 1 over 0. It's not 0. Okay, dividing by 0 is undefined. So the tangent of 90 degrees is undefined. That's it. This is what we're going to be doing today. We are going to be answering the questions on the bottom based off of that chart. Okay, this chart's going to be important. You're going to see these angles all the time, 30, 45, 60. You're going to be asked for the sine, the cosine, the tangent all the time, and everything's right there. So once you know this chart, you've got everything you need. So what is the sine of a 45-degree angle? Sine 45 is radical 2 over 2. Radical 2 over 2. You are done with that problem. Number 3, what's the cosine of a 60-degree angle? Cosine 60 is 1 over 2. That is all you're doing. Okay? Tangent of 30, write it down. Radical 3 over 3. Now, sine of 0. Now, what 0 is that? It's actually 0 radians, but 0 degrees and 0 radians are the same, but the fact that you don't see a degree sign tells you that that's in radians, actually. Okay? So, sine of 0 radians is 0. Okay? Easy peasy. How about the next one? Secant. Ooh, wait a minute. The secant of pi over 6. Now, I do not have secant up here. But what do I know? I know that secant is the reciprocal of... Do you need to turn your page back? You need to see what that is? Secant is the reciprocal of cosine. Okay? So what we're really going to do is this. We're going to use our chart, and we're going to find the cosine of pi over 6. And then we're going to do the reciprocal of that. We're going to do 1 over... That's how you say the reciprocal of something. We're going to do 1 over the cosine of pi over 6. Okay? So we're going to go to our chart. Cosine. Now, we're looking at the radians, pi over 6. Cosine of pi over 6 is radical 3 over 2. So we need to take that and we need to flip it. Okay? So radical 3 over 2 is our cosine. So our secant is 2 over radical 3. Just write it like that. And then fix it. Okay? So take the value that we know, flip it, And then if you need to rationalize it, then do that in a second step. Don't try to do too much stuff in your head. Okay? So this is our secant, but we're going to write it as, we're going to bring the radical 3 up. Then we're going to write the radical 3 without the radical. That is the secant of pi over 6. Okay? Look at the next one, 7. What is the cotangent of pi over 3? So the same thing. We're actually, we don't have cotangent on our chart. So we're going to do tangent, but then we're going to do the reciprocal of it. So tangent of pi over 3. So again, just find where they meet. Tangent, pi over 3 is radical 3, or radical 3 over 1. So the cotangent would be 1 over radical 3, but then I have to rationalize that. Radical 3 over 3, that is my answer. I'm all done. Okay, what's the next one? What's the cosine of 90? Cosine 90 is 0. That's it. How about the secant of 90? Well, so again, what is secant? Secant is the reciprocal of, it's the cosine. So I want to do the reciprocal of what the cosine of 90 is. Well, cosine of 90 we just said is 0. So look at what I have here. I would have 1 over 0. That's undefined. You can't divide by 0. The reciprocal of 0 is undefined. This is a 0. There's nothing wrong with that. But as soon, and the reason it's okay, it's because that 0 is in the numerator. That's all right. As soon as you flip it, it moves it to the denominator, so that would make it undefined. Okay, so the reciprocal of 0 is undefined, and the reciprocal of undefined is 0. Last one, sine of pi over 2. Again, go to your chart. Sine pi over 2 is 1. You are done. Okay, so use your chart. That's what you're doing today. You're going to familiarize yourself with all these values, and also you may have to find some reciprocals. So those are a little trickier. So let me know if you have any questions. Thanks.